This is section 4.3, using congruent triangles. So we know what congruent triangles are. We know how to show we have congruent triangles, either with SSS, side, 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 ASA, angle, side, angle, or SAS, side, angle, side. In this section, we're going to use those to show the triangles are congruent, and then to be able to say other things about the parts of those triangles. So as I've written here, we can use congruent triangles to prove things about segments or angles if we know that those segments or angles are corresponding parts of congruent triangles. For example, if we're given segment AB and segment CD bisect each other at M, and this picture I've drawn here of these two triangles, and we want to prove that segment AD is parallel to segment BC. We want to show segment AD is parallel to segment BC. We start in this proof with what we're given. AB and CD bisect each other at M. That's our first statement. What is our first reason? Given. Good. So I know that if two things bisect each other, by the definition of a bisector, that means it cuts them into two congruent pieces. So that's what I'll state next, is what congruent pieces I have. Well, if AB and CD bisect each other, then AM and MB have to be congruent, and DM and MC have to be congruent. So I will state those. Segment AM is congruent to segment MB, and segment DM is congruent to segment MC. I'm stating them together because they're both for the same reason, and that reason is definition of a bisector. Because those two segments bisect each other. They each cut each other into two congruent pieces. And now I've indicated those congruent pieces on my picture with those single hash marks for AM and MB, and double hash marks for DM and MC. Alright? Now, do I know that these triangles are congruent? Well, I have two sets of sides that are congruent. I don't see a way I could get the other pair of sides congruent, but I do know that I have two angles in the middle here that are congruent because they are what kind of angles? Good, vertical angles. Very good. So I know angle AMD is congruent to angle BMC, because those are vertical angles, and we know we have a theorem that says vertical angles are congruent. So now I have a pair of sides, an angle, and another pair of sides where that angle is between those two pairs of sides. So then I have congruent triangles. And I can state triangle AMD is congruent to triangle. What angle corresponds with A? Looks like B. What angle corresponds with M? It's M. What angle corresponds with D? It's C. So triangle AMD is congruent to triangle BMC. Why? Angle. No. Why? Side, angle, side. Very good. The side, angle, side postulate. Now I'm not finished, because I wasn't just trying to show that those triangles were congruent. I'm trying to show that AD is parallel to BC. I'm going to use those congruent triangles to get me where I want to go, though. I could show that AD is parallel to BC if I could find a pair of alternate interior angles congruent. So if I could show that, say, angle D here was congruent to angle C up here, then I would know that AD was parallel to BC, because those are alternate interior angles. Well, how do I know that angle D is congruent to angle C? Because those are corresponding parts of my congruent triangles down here. I know D is going to correspond with C. So I can say angle, in this case we can call them just angle D and angle C because there are no other angles with those vertices. We can also call them angle ADM. And that's congruent to angle BCM. Now this reason is a reason we're going to use a lot in this section, in this chapter, and for the whole year. Anytime we start with congruent triangles and we say that pieces of those triangles are congruent to each other, the reason we use is written like this: corresponding, which I'll abbreviate like that, parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. I start with congruent triangles. I know the pieces of those triangles that correspond to each other have to be congruent. Way back from section 4.1. So you'll see that reason a lot. Anytime you have congruent triangles, and you're using those to give you pieces of triangles congruent. Okay, now that I have those angles congruent to each other, I can say what I want to say. That AD is parallel to BC because I had alternate interior angles congruent, and that implies parallel lines. So now I'm finished. Used what I started with to give me congruent triangles, which got me alternate interior angles congruent, which then got me the parallel lines that I wanted. So that's the idea of this section. Using congruent triangles to prove other things. So using them within proofs of other things. So we're going to do one more together. We have this picture. That's a plane. The green flat thing is a plane labeled X. And we have two triangles that are sitting straight up on top of the plane. So this is your plane. Triangles are sitting straight up like this. Okay? Only the bottoms of the triangles are sitting in the plane. Everything else is above the plane. We're given segment PO, which goes straight down vertically through the plane. It's perpendicular to plane X. For a line and a plane to be perpendicular, that means that line is perpendicular with every line that lies in that plane at that point. And we know AO is congruent to BO. So I'll mark those things on my picture. PO is perpendicular to plane X, so I have a right angle there. And I have another right angle there. And I know AO is congruent to BO. So that is congruent to that. I want to show that PA is congruent to PB. My strategy will be this, similar to the one on the last proof, which is to come up with congruent triangles, and then I know PA and PB are corresponding parts of those congruent triangles, and so they would be congruent. So if I'm going to come up with congruent triangles, I'm almost there. I have one set of sides, AO and OB. I have a set of angles, these two right angles in the middle. I just need one more set of sides that would have those angles in between them, so I need PO congruent to itself. But we know that's true by the reflexive property. So let me just write all of that out. We start with what we're given. PO is perpendicular to plane X. AO is congruent to BO, given. number 2. Since PO is perpendicular to plane X, that means angle POA is congruent to angle POB. They are both right angles. So angle POA is congruent to angle POB. The reason? Perpendicular lines form congruent adjacent angles. Those angles are adjacent to each other, they have to be congruent. Now, I know PO is congruent to itself. Why do I know that? The reflexive property. Reflexive property of equality. Something is always congruent to itself. So now I've stated one pair of sides, another pair of sides, and the angle between them are all congruent. Then I can have congruent triangles. Let me make sure I state these in the right order. If I say triangle PAO is congruent to triangle, I'm going to label the other one then as PBO. And that would be side, angle, side postulate. Okay? Now I wanted to show that PA was congruent to PB, and I can get that straight from these congruent triangles. PA is congruent to PB. The way that I've written them out, which is the correct way to write them out, shows me that they correspond with each other. So, segment PA is congruent to segment PB. Again, the reason is corresponding parts of congruent triangles are congruent. And then I'm finished. I used congruent triangles to show what I wanted to show. Here are your immediate practice problems. You have a picture, triangle JLK, which is divided into two smaller triangles, triangle JLM and triangle KLM. You are given that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. You're asked to complete the proof and prove that M is the midpoint of segment JK. So by complete the proof, I mean you're going to write down the entire proof and fill in these red blanks. Let me try to get all of this on the same screen here. There you go. You're going to complete that proof. So I left the first statement and the first reason blank. You need to fill both of those in. Second statement, that LM is congruent to LM. Give me a reason. Third statement, triangle LJM is congruent to what triangle? Fill that in and give me a reason. Then you're told JM is congruent to KM, and that's because corresponding parts of congruent triangles are congruent. And then you're told M is the midpoint of JK, and that's by the definition of what? Fill it in. So copy that entire proof and the picture and fill in the 6 red blanks. That is the end of section 4.3.